Hello. So, in this question, we have to calculate the moment of inertia for a ring about this axis. This is our ring. The mass of the ring is given m and the radius of the ring is given r. So, in case of ring, we know the moment of inertia about the ring passing through the center of mass perpendicular to the ring. So, moment of inertia of the ring about O1 formula is mr square. This is the formula. We did the derivation, we know that. Now we do have to calculate the moment of inertia about this axis. Between these two axes, the distance is r. So what we will do, we'll use the parallel axis theorem. Parallel axis theorem we will use because these two axes are parallel to each other. So according to parallel axis theorem, moment of inertia about the second axis will be equals to moment of inertia about the first axis plus m x square, where x is the distance between these two axes. In this case, it is r. Okay. Let's put the values. I01, that is m r square plus m, in place of x, we'll put the value, that is r square. So moment of inertia becomes 2mr square. This becomes the moment of inertia for this ring about this axis. Okay, that's how we use the parallel axis theorem. Not just about this axis, we can calculate the moment of inertia about some random axis also, which is having a distance r by 2, you can say. Or about this axis also, because these two axes are completely symmetrical to each other. So it will be same, 2mr square across each and every periphery. If I want to calculate the moment of inertia here, in place of x, I have to write the r by 2. And in that case, it will be equals to I03 is equals to I01 plus m times of, in place of x, we'll be writing the r by 2 whole square. So if we put the values, will be mr square plus m r square by 4, and that is going to make this I03 as 5 by 4 m r square. That's how we use the parallel axis theorem. Okay. Thank you.